So, hello. So today we will discuss about the lesson 33. In 32 we have discussed, that is elevation in boiling point, and we have delta TB equal to KB into W solute into 1000 divided by M solute into W. So from this we have delta TB into M solute into W equal to KB into W solute into 1000. Yes or not? So this is, so that implies M solute equal to KB into W solute into 1000 divided by delta TB into, delta TB into W. So M solute, you know that M solute is the molecular mass of the solute. This is the molecular mass of solute. So from the colligative properties, so from this, so from the elevation in boiling point, elevation of boiling point, we can calculate the molecular mass of, solute. Yes. And we know that delta TB proportional to M's. That means elevation in boiling point is depends on the number of solute particles. Okay. So from this, M solute equal to what? M solute equal to KB into W solute into 1000 divided by delta TB into W. And M solute is what? M solute is molecular mass of the solute. And also from these equations, this is the elevation in boiling point. So from the elevation in boiling point, we can calculate the molecular mass of the solute. Same the thing here I have written. Now from the elevation of boiling point, we can calculate the molecular mass of the solute. So again, I can write, that is, we know that delta TB proportional to M. M is the molality of the solutions. That means elevation in boiling point is depend on the numbers of or amounts of solute particle present in the solution, but not depends on the what? Nature of solute. Hence it is called a colligative property. Hence it is called as a colligative property. This is all about your elevation and boiling point. So we know that what delta TB proportional to m is the molality of the solutions. So that means if the number of moles of solute will increase, then delta TB will be increases. That means boiling point of the solution will be increases. So that this is depend upon the amount of solute or numbers of solute present in the solution, but not depend upon the what? And nature of the solute. Hence it is called colligative property. Okay. Hello. Now we will discuss about our third colligative property, that is depression in freezing point. So depression in freezing point. So freezing point. The freezing point is the temperature at which a liquid changes into solid. So, what is freezing point? Freezing point is the temperature at which liquid changes into solid. Okay, so say temperature को हमें कौन कहबा freezing point कहबा जो temperature रे solid liquid टा कौन है जीवा solidified है जीवा. Okay. Here a solidified means what? Turned into ice. Ice is a solid one. Yes or not? So similarly, freezing point. The freezing point also defined as the temperature at which both liquid and solid coexist and have same vapor pressure. So freezing point also defined as the temperature at which both the liquid and solid coexist करिए गोटे particular point temperature both particular temperature in a particular temperature both the liquid phase and solid phase will coexist and also having the what same vapor pressure. This is called your freezing point. So depression in freezing point means depression in freezing point means decrease of freezing point of solution due to addition of the non-volatile solute in solvent. So, suppose this is a container, and in container, suppose there is having pure solvent. After adding of the solute, suppose I add the solute. After that, it turns into solutions. So, its freezing point will be decreases. Why it is decrease? Because of the addition of the what? The solute. After addition of the solute to the solvent, the solution freezing point decreases. So this can be drawn in the graph. So suppose this is temperature plot, and suppose this is vapor passage axis. Suppose this is I take T not F, and this is I take TF, and this is the solvent, and this is solutions. Okay, so here what happens, this factor is called delta TF. So our graph says that here what happens, suppose T naught F is the temperature at which the solvent vapor passage was there, and TF is the temperature at which this is the vapor passage of the solution is there, and this delta TF is the depression, is the freezing point. So here T naught F greater than the TF, so T naught F minus TF equal to delta TF. So here we can write, let the freezing point, let freezing point of the solvent equal to T naught F, and freezing point of the solution equal to TF, solution equal to TF. Thus delta TF equal to T naught F minus TF. So this is delta TF means change in temperature, freezing point temperature. This is calculated from T naught F and TF. T naught F is the temperature of what? Your solvent at which it start to freeze, and TF is the temperature at which solution start to freeze. But it is here seen that TF is less than T naught F. That means solution have lower freezing point, and this lower freezing point happens due to the addition of the solute in the solution, in the solvent. So mathematically we know that TF is proportional to M, that is M is the molality of the solution, and TF we know that what? This is your depression in freezing point. Depression in freezing point. Suppose this is equation 1, that implies delta TF equal to KF into M. Here KF is called cryoscopic constant, or it is also called molar depletion constant. Okay, it is called molar depletion constant. So same the thing, we have to put here the value of what? The value of the M. M is the molality. Suppose this is equation 2, and we know that molality M equal to W solute. In case of solute, you can also put B, WB. So W solute by M solute into 1000 by W by putting the value of M in equation 2, by putting the value of M in equation 2, we have, that means here what happens, delta TF. Previously in equation 1, we see that delta TF proportional to M. M is the molality of the solutions. Second equation, we see that here delta TF equal to Kf dot M. Kf is a constant here. This is called a cryoscopic constant or molar depletion constant. So we know that M is the molality. So what is the value? How can we calculate the molality? Molality equal W solute by M solute, 1000 by W. And I said that W is the what? W solute is the weight of the mass of the solute. This is the molecular mass of solute. Capital W is the mass of the solvent. So by putting the value of M in equation 2, we have this is your what? This is your delta TF equal to Kf into W solute by M solute into 1000 by W. That implies M solute equal to how much? Kf into W solute into 1000 divided by 1000 divided by what? 1000 divided by your delta TF into W. This is your M solute, and you know that what is M solute? M solute is what? Molecular mass of the solute. So M solute, your M solute is what? Here M solute here is your molecular mass of the solute. So from the depletion in freezing point, we can calculate the molecular mass of solute. So same the thing we can write here that by the help of depletion in freezing point, we can calculate the molecular mass of solute and also T delta F proportional to M. That means depletion in freezing point depends upon the numbers of moles of solute present in the solution or amount of solute present in the solutions. Hence, it is a colligative properties. Same the thing I written there in the elevation in boiling point. Okay.